Let's start from the bottom of the coding style modeling, introducing the structural modeling. The structural modeling is very similar to the schematic entry, in this case implemented as text instead of graphically. As digital design becomes more complex, it becomes less likely that we can use only one of the three implementation styles seen before. The result is the use of the hybrid vhdl model. The term structural modeling is the terminology that vhdl use in the modular design. I mean, if you are designing a complex project, you should split in a two or more simple design in order to easily handle the complexity. The benefits of modular design in vhdl are similar to the benefit that modular design or object-oriented design provided for higher-level computer languages. Modular design allows you to pack low-level functionality into a module. This approach allows a design reuse without the need to reinvent and retest the wheel every time. Next step is the hierarchical approach, where you can extend beyond the structural coding modeling. In this case, in the top-level entity are instantiated a design 1 with two subdesign 1 and 2, and a design 2 with two subdesign 3 and 4. In order to instance a component inside a design, you shall declare the component in the declarative part of the architecture, instance the component in the architecture statement section. The declaration section of the architecture is included between the keyword is and begin. The statement section or concurrent section of the architecture is included between the keyword begin and end. The declarative part inside the keyword begin is and begin. The statement part or concurrent part is between the keyword begin and end architecture name. The component declaration to be inserted in the declarative section of the architecture can be summarized as follows. Copy the entity declaration relative to the component. So, copy all this one. Replace the keyword entity with the keyword component and delete the keyword is. Replace entity with component and delete the keyword is. If you use vhdl 1993 standard or above, you can bypass this last step. Then replace the entity name after the keyword and with the keyword component. The entity name with keyword component. For the component instantiation, copy the component declaration in the architecture concurrent area. Replace the keyword component with the instance name and add the keyword map after the generic and port clause. So, copy in the statement part, replace the keyword component with the instance name and add keyword map after the generic and port clause. In order to map generic and port, replace the comma with the two symbol equal greater than and replace the semicolon with colon. So, replace the comma with equal greater than and put the signal name and replace the semicolon with colon. Maybe an example will clarify better than thousands of explanation. In this example, we want to realize the structure implementation of this entity and or. There are 4 input ports, A, B, D, and E, A, B, D, and E, and 1 output port, G. The instance U1 and U2 of the 2 AND gate are connected to the U3 using 2 wires named C and F. In this moment, we don't care about the architecture of N2 and OR2 entity. It could be structural with another component instantiation or behavioral. Let's see the architecture of the AND/OR entity to understand better the structural instantiation. In the architecture declarative part, we found N2 OR2 component declaration, signal C, a signal F that represent the connection between the output of U1 with the input port OR2 and the output port of instantiation U2 with input port OR2. In the statement section, we found the component instantiation. Now pay attention to the port mapping. The port A and B and C mapped in the instance U1 are respectively the entity input port A and B, and the output port C is connected to the signal C. On instance U2, the port A is mapped on port D. The port B, input port B, is mapped on port E. The port C on internal wire signal F. On instance U3, the input port A is mapped on signal C, the input port B is mapped on signal F, and the output port C is mapped on output port of the entity and/or G. As general rule, the port entity are signal inside the architecture. The input port can only be read. The output port can only be written. If you try to read from an output port or try to write to an input port, the simulator will raise an error and stops.